points, and what did you rule out and why?
Everything but C and D.
Everything but C and D?
Oh, that's number 2. Never mind.
Okay, well that's number 1.
I go with A.
What did you rule out and why?
A.
How come?
Because if you do the
If
first
X is
quadrant,
negative, it should be a positive and they're all down?
Yeah. If it's a negative.
Is there anything else where if X is a negative, it should be a positive?
D. Oh, and also
C?
oh.
No. No, well, I'm just looking at second quadrant, so X's are negative, Y's are positive, those 2 are ruled out. Can you guys rule out another one?
I said
E?
E.
D, how come?
Because when X is negative, the slope depends on if it's the same negative. If I was in the very left one, it depends on the Y, but as the Y gets bigger in the negative direction, the slope is increasing.
So Noah's realizing as the Y's get higher, it gets more negative, so then that doesn't really make sense with D, but also you could say in the first quadrant, doesn't everything have to be positive? Do you guys see some zeros and some negatives right around here?
That's pretty good.
That's impossible, so either way, D is out, that's true.
Then let me see though.
Couldn't we say C is out also? And it also makes sense, because C, once again, first quadrant, everybody had to be positive, but I see a negative right there. But you could have also checked other quadrants. Did anybody know the quadrants other than 1 and 2? I just did 1 and 2. I did 3 and 4.
Oh,
You just did quadrant 3. Negative and negative, that's a good one.
Negative 1, negative 3.
Yeah, 3 and
You
1.
did 4?
Yeah.
3.
Negative 3 and negative 2.
Anyway, final answer, E, I agree. Okay, number 2. How many of you guys got E? Number 2.
Oh.
No. Sorry, I was doing it, but then only half the class got E, so I was just making sure. Any questions on one? We okay?
E for me.
Okay. Number 2.
C.
C?
D. It's C or
I'm
D?
guessing C.
It's C or D, one of those.
Well, if you, or I should say, if square root of X is being made Y, what else would you have to change?
Bounds.
You have to change the bounds, because this could be like a, you could have made it like a U if you want to think about that. U is square root of X, and then they made that sign of Y. So if you want U bounds, these are X bounds, right?
Yeah.
Okay, so if
You plug it in, make
well, I
Y
didn't want
bounds.
to do that. Yeah, I'm just trying to get you the idea of plugging in X's, right?
Wouldn't it be positive?
So if you want to get the bounds, you could plug in 1/2. What's the square root of 1/2? 1 over root 2, which is root 2 over 2. So what could Y be? It could be pi over 4. Definitely couldn't be pi over 6. That makes no sense. These ones don't even have pi's. Forget them.
Yeah.
Okay, so we're down to C and D.
That's D, you ran out of
C,
answers.
E, and B all have 2's in front, so most likely it's C.
Okay, so then they were thinking possible elimination, 2, 2, 2. What are you doing with 2, 2, 2? Hold on, what if you put in 0? Square root of 0. What sign?
0.
When is sign 0, I should say?
Well, they both have the same bound.
0.
Okay, so sign's at 0. So why are they doubling? Did anybody figure out why the 2? Besides just process of elimination, and a lot of the other ones had 2, so let's pick C. That's isn't bad, that's good logic.
That's how much you think? Or is it that?
It is how it is.
Because,
No?
Is it because it's absolute value?
it's like a square root.
It's squared.
Absolute value.
You just plug in sign of Y for this one. You guys are struggling with this one, right?
Yeah.
But did anybody ever find dx?
No.
We gotta go to dy somehow.
Oh, so you make that U?
So couldn't we go ahead and take the derivative of both sides? What's the derivative of the left side?
Y.
What's the derivative of the right side?
dy.
So then what? Multiply up the dx and, right? So wouldn't you then have dx is equal to 2 root x cosine of y dy?
Yeah.
Okay. So then we can pull in the 2 root x. So we have, what do we do with that guy though? The 1 minus root x? Couldn't we solve for x with integration on track?
Yes, ma'am.
So then x equals sine squared of y? Did no one actually solve this one all the way?
I got stuck.
Do it logically.
So then, if you go ahead and plug in, what do we have? We have 0 to pi over 4. Square root of x is going to equal sine of y. We have square over square root of 1 minus sine squared of y from solving for x and plugging in, times 2 root x cosine of y.
Cosine cancel out.
1 minus sine squared is cosine squared. Cosine squared square rooted is cosine, technically absolute value of cosine if you want to think of it that way. But in a sense, you don't see any cosines that are left, so we'll just say they canceled that one out. And then you can separate, or I should say you can plug in sine
For square root of x.
So that's
for square root of x. And so why is it 2? Partially because of the u prime. But, I know, but be careful. There's only 4 answer choices in the AP, so 2 will have 2's and 2 will not, then what? Alright.
That's a risk we can take.
We can take that.
Alright, number 3.
Is it A?
Oh, that just got small. Who has a defense for why it's A if it is A?
Ooh, tabular method.
Yeah.
Not on this one, why would you?
You can do it in your head.
You do it in your head this way.
You
You would just make that x, you would make this e to the 2x, so then you would go back to 1/2 e to the 2x. And then d is equal to 1 dx.
Once we plus minus, so 3 of them cancel out already. Then if you do the second one integral twice, it's 1 over 4, so it's A. Thanks, Donna.
You know it had to be minus so people to see the E.
Double check just in case
And
you
there's
give us e to the negative 2x, right? Just be careful. If it was e to the negative 2x, it would be a plus.
1/2.
But yeah, you're right. That one's out, this one's not going to be there either. And then when you multiply the 1/2 by another 1/2, it will be 1/4.
I got that one right.
Okay. What about the last one?
I didn't look at it.
Well, the thing looks like this.
Sketch the solution curve through 0, 1. You see the point, right?
Wait, is that
What's going to happen?
is that a straight line?
Uh-huh.
Where's 0, 1?
Yep, and the other one is a down.
But then if you do the 0, negative 1,
Yeah,
it has like a
one of those.
slanting asymptote seemingly, something like that. How about letter B?
There's a value.
They love doing this kind. I've seen it recently quite a few times.
Well,
There's a value B for which y equals 2x plus b is a solution to the differential equation. Find this value of b, but how?
Plug in.
It'd be great.
Plug in what?
and then well, derive, plug in 0.
You don't integrate, it's impossible.
Derive.
You have a 2y minus a 4x, it's impossible to integrate. So I know that you're thinking if I could, I would, but you can't. So what else can you
Plug
do?
in 0, 1.
Point slope form.
Point slope form, you can think about that, or you can just take the derivative of this, y prime will be dy dx, right? At least at this point. Or you can think of the slope of the tangent line, isn't that a derivative?
Nope.
So you can set this equal to 2.
Solve.
Solve for y, is that what we're solving for? Plus the 4x divided by 2, so 1 plus 2x.
1.
So that would be y.
But then what else do we have to think about?
Justify. Also, is it different?
We put back into that.
Wait, what do you do with top part? You do solve for dy.
We set the slope equal to 2 because the slope of the tangent line is 2. And then I solved for y, so I added the 4x and divided everybody by 2, so 2x plus 1 is equal to y. But how do you find what b is? Yeah, compare the two. So you have 2x plus 2, and then 2x plus, oh, okay. So we can go ahead and say b is equal to 1. Or we could have also thought about plugging in 2x plus b into the y, and then solving. Justify your answer, I would talk about something to the effect of the slope of the tangent line is dy dx, and then you set equal to and solve. What about letter C though? Let g be the function that satisfies the given differential equation with the initial condition. They give us a point. This sounds like solving. But now it says it appears from the slope field g has a local max at the point. They're not telling us to solve the differential equation. Telling us to use the slope field. They're saying, hey, it sure looks like at 0, 0, this is a max.
Yes, ma'am.
How do you prove?
Oh, you go from left to right.
You draw the
But
graph
how do you plug in a point right before and right after 0, 0?
into the thing. You
What you
just
think?
then
You
you
do a sign chart?
point slope form.
Like, you go from -1 to 1.
But how do you know exactly where the critical numbers and that you need to separate are?
You have the form.
No, you don't have the formula of the original, you only have the
Well, you
formula
have
of the...
y equals 1 plus 2x, can you plug that in?
But how many different zeros can you get of the dy dx?
Many.
Different critical numbers, infinitely many.
Well, didn't
Yeah.
they give us a...
Because you can have different y's with different x's.
But didn't it say that local max?
You can look at the slope field, but they told you from the slope field what the slope field says. So how do you prove it?
They gave us a point so you can plug it in and if we could.
You can plug it in and prove it's a critical number, that's true, dy dx at 0, 0 is equal to 0, that's true. So there is a critical number, but does not prove it's a max. And I'm telling you, you can't use a sign chart because there are infinitely many zeros, so how do you make a sign chart separating? Properly.
You go from the thing and that.
Point plug in
Like a
and
negative 1.
Oh, there are two ways to find a relative max. One is with the first derivative sign chart. The second is with the second derivative. I can take a second derivative just fine.
Oh, yeah.
How do you take a second derivative?
Well, it's 2y dy dx minus 4.
Well, first of all, taking the derivative that side.
So it's 4y minus 8x minus 4 over minus 4.
You plug in, right?
Yes, ma'am.
You want to plug in such that you have the point 0, 0. So if you plug in 0, 0, what's your d squared y over dx squared?
-4. Calm down.
Oh, the 3 dots mean that therefore or?
No.
Yeah.
Okay.
So did it say y equals f of x? Oh, g? Should write the notation. There exists a backwards e. Just a backwards e. There's like an extra mark, sorry. It's really low.
Where is it? There it is.
There exists. Oh, that's what it was supposed to be. Oh. A relative max of g at 0, 0. Nicely done. Pause. You cannot. For a slope field, you can look at it and approximate like they did. And they told you use the slope field, which is good. You can see it, but how do you prove it? Second derivative test. You cannot do a sign chart just with the slope field. It's not enough. Especially if you have y's and x's. You could have set the derivative equal to 0, found the critical numbers, and thought of it that way. But there are infinitely many zeros when it's dependent on y and x. Okay, with that, let's go ahead and open up in our notes. I want us to finish these last 2 examples that we kind of started yesterday. This is the first one. Tic-tac-toe, stand delivered. Actually, there's a picture in your book of him doing tic-tac-toe, I think, or at least of stand delivered. No, I don't think. No, he was. He was back and he was talking. The kid was on the board saying, "I don't want to help me, please." You're supposed to say no. Anyway. You guys better remember that part of the movie, but. Is it Angel? That was his name, right?
Yes.
My baby. Oh, yeah, that's right.
It's right here.
He was the slightly chubby guy that was dating.
Yeah, just like each other. What is his name now?
He said slightly chubby.
Remember he was up here and he was like, I can't do calculus, you guys will be better off without me. He said, don't do this. Every year. I mean, I watch him. Yeah.
That was so funny.
It's a good movie though, it's a I'm grading and stuff in the back while I'm doing it, usually like at Park Hughes or something.
Can we watch the Netflix after we do the AP exam?
But I like that part, because he's back there, he's like, do you want my help? He's like, yes! And he's like, you're supposed to say no! I need a 10! Anyway. To help, yes, not do the problem for you. Kind of.
Right.
Okay, question. Do you guys understand why I was saying this might be nice to have some sort of shortcut method of solving?
Yes.
Because every time I do integration by parts, it's only going to go down 1 power. And I'm still going to have a problem. I'm still going to need to go again. So we could do repeated integration by parts. U and dv and U and dv and U and dv. However, you could also set up a table. Now Jason's like, you can always set up a table. That's true. So maybe we'll go look at the one that you guys were doing in multiple choice and see if you like the table better. But the idea is I can start with x to the 4th and say, okay, if I derive and derive and derive and derive and derive, eventually he'll be gone. Eventually he'll be gone. But while I'm deriving the u in the integration by parts, what am I doing to dv?
Integrating.
I'm integrating. So the integral of sine of 4x, mental math with you said,
1/4
negative 1/4,
cosine 4x.
right?
Negative
We're going to leave out the dx's because once you integrate once, remember the dx comes from over here. So we'll leave the dx's off. Yeah.
What are the slashes?
We'll come back to them in a second. Hold on.
Negative 1/16 sine.
Oh, is it what matches with it?
1/16 sine 4x.
Positive.
Positive
64 cosine 4x.
Positive
256 sine 4x.
Sine of 4x. Negative
1
512.
yeah.
Oh my
Wait,
god.
no,
No,
because it's 4, right?
Yeah,
You have to do 4.
Oh, I was doing 2. Yeah, I was doing 2.
10,
Is it 1080?
1028. 10,
Oh, 1024, yeah. Because you guys know, like, computer stuff always comes in these increments. So when they were doing, like, maybe you don't remember, when they're doing flash drives that were, like, megabytes? Yeah, megabytes.
Oh, the 250. Oh,
Yeah, 256?
Yeah.
Or 1024, or 512, or...
1000.
Oh, 1 gig, yeah. But this came up in, when you're talking about bits, this can come up.
This one?
I think so.
Then you're
What
gonna
is it?
do
You keep on going.
Coffee of blood.
Yeah, because it's all in increments of 4. Or powers of 4. Okay, I drew lines yesterday, and Stan delivered, he did it this way. He was like, tick, tack, toe. Like, that's what he did, and you only had 3. That's why I said tic, tac, toe. Mine has more than 3, so it doesn't work. And I don't like the way he did it with the, like, whoosh, whoosh. I don't like that. I just like the straight connections. That's what I do. The long story short is you would have uv, because the integral of dv is v. uv minus the integral of v du, which ends up being uv, another uv, minus the integral of another uv, another uv, another uv, and eventually you're down to where you don't have any left. So, what we have to keep in mind though is when we do uv, the next sign is going to be opposite, because it's going to be minus the integral of. But then the next one's going to be opposite and opposite, so we can think of it as a plus and a minus and a plus and a minus and a plus, because every time with the formula uv minus the integral of, you're going to flip the sign, but then sometimes you flip the flip sign so it gets back, and then you flip the sign and you flip the flip sign. Long story short, when you solve with the tabular method, you can think of basically this is your solution. There's no integration left to do. But you just have to go ahead and rotate the sign starting from positive. So your final answer is going to be the following. Negative 1/4 x to the 4th cosine of 4x. Minus a negative, which will be plus 4 over 16 is 1/4 x cubed sine of 4x. The next one's going to be plus, no negative, so plus 12 over 64 reduces to be 3 and 16, yeah, 3/16
Now I see what
X
it's
squared
useful in research and
cosine of 4x. The next one's going to be minus
332.
It just keeps going, Miss
Sine 4x.
Is that
You have x to the first power times sine of 4x. So we're multiplying and simplifying.
is this what you don't like?
The next one's going to be minus 24 over 1024.
She doesn't really like using it as
Oh,
a
it's 3/128.
and then I
No,
can
it's
see
useful for this kind of stuff.
Cosine.
But don't forget,
Plus c.
No, it's good for
For everybody else, what am I doing? I am taking the connections of the lines. I have to put a plus C at the very end because it is an indefinite integral. That's a dilemma of the tabular method, is forgetting the plus C. But you multiply the two together, and that's your first part of your answer. Take the sign, multiply him by the other two. So negative times negative was a positive. 4 over 16 is 1/4 x cubed. That was my second term. Plus, that's a positive. 12 over 64 reduced to be 3 over 16. Keep the rest. That's the third term. Fourth term, fifth term, add a plus C. We're out of terms. The next one would be 0. It's ultimately doing integration by parts. 1, 2, 3, 4, 5 times. Well, 4 times technically, because then you would solve the integral the last time. Or,
Can you just explain again how you get the positive and negative?
oh, that is what you need to do. But long story short, if you were solving this, this is u times v.
Yeah, okay, exactly.
Minus the integral v du. So when you go to take that integral, you're going to end up with this u and the next v, because this is now a dv. But it's with a minus. So what we do is, as we're going down,
So they're all minus, okay.
they're all minus, but the problem is the next one would be minus a minus.
Yeah.
Minus a minus a minus. Minus, minus, minus.
Could you do the little table on the side like how they did, I think they did in the movie where they put it on the side with positive and negative, positive and negative.
Yeah, technically you could. The reason I like it on the actual slash is for me to remember, because otherwise on the side it kind of, I guess you could go like over.
Oh yeah, I do that.
You could do that.
I do the over.
So you go that.
No, it's I go straight to the positive side, then diagonal down to the other side.
Oh.
So it's
Okay.
it's easier for me to connect the two together.
Oh, that's sad.
Whoa.
No, I do it.
What Noah's saying is that if you have the x and then you have the negative 1/4, sorry, x to the 4th, cosine 4x, he puts a positive and he goes down,
Yeah.
like that. But you can go over and then circle and then down.
It's a good system.
Yeah.
So let's go back to that multiple choice one that we did just a second ago in your notes. You guys have to do it again, but would the tabular method work?
Yes.
Okay.
That was nutty.
The integral was, guys, we're falling farther and farther behind. We have the integral of x times e to the 2x dx, true?
Yeah.
There's not a huge power of x. You might think there's no purpose to the table. Well, it just depends on your brain and whether or not you like the table. So if you were to pick the u as x, couldn't you take the derivative and you got it? Yeah. Could you take your e to the 2x and then do 1/2 e to the 2x and then 1/4 e to the 2x?
Plus minus plus.
You can,
Plus minus.
I haven't done that yet. We've stopped because we've reached the 0. Then we could go ahead and say, as they were doing, you could say, like, do a plus first and then a minus and then a plus. And so then Noah's saying you can go down and then go down, and then we're done.
Okay. You're a genius, man.
If that, well, if you like it.
That's a
You
proton
can
and
use it.
electron.
So if you want that, you can do that for integration by parts. You mean this times this and then that times that.
Tic-tac-toe, you need 3 things. How's this tic-tac-toe?
That works as well.
Where's the tic-tac-toe? You need 3 things for tic-tac-toe.
That's true.
There's 2.
I know, he called it tic-tac-toe, I don't for that very reason. I call it Lucky 7 and I do it the other way, because sometimes in the AP you do need to know the formula, u times v minus the integral of v du, because you know they don't always give you the function.
Where's the 3-way?
Alan.
Does this ever not work? Yeah, there's
Sure.
integrals you can't solve, right?
Besides one's endless, right?
No, if the
How about
if the
this
D
one?
isn't,
Yeah.
Remember I told you yesterday? Remember I told you yesterday, what if you had 2 of the problem ones that cycle back and forth with their derivatives? I personally wouldn't want to use the tabular method for it. Because in my mind, I don't keep track as well of what's exactly going on. The tabular method is a shortcut. But some of you might like the tabular method to the extent of you fully grasp what's going on and then you go ahead and show it. But for my purposes, let me show you how I would do this one. And for those of you guys that know, please don't say anything. Solve it and then just sit and wait. Because, in a sense, when you just give a quick answer, you're shortcutting their learning process. So, coming back. Try to think of it as how you would explain it. That's not a bad thing, because maybe it'd be different than me, probably would be. The problem on this one, Liate, we have both an exponential and a trig. Problem is on both of them, whichever one we choose to be u, will end up cycling and not simplifying. According to our integration by parts, we want u to be something that derives to be simpler and dv to be something that can be integrated. We saw yesterday sometimes if we just go with like, oh, always do this or always do that, it's not always a good idea. But in this one, they're both going to cycle, so long story short, you just pick the one that you would rather be integrating. Or you just pick the one that you'd rather be deriving. You got to choose one to be u, the trig or the exponential, and whatever you choose, since you have two that cycle, whatever you choose to be u, I'm just going to tell you spot on because you have too many kids in here who know what's going on. Whatever you choose to be u, keep it that way. Because if you make exponential u one time and then you make the trig the u the next time, you're going to come right back to the beginning and nothing will have been solved. Okay. So who do you want to be u the first time? Trig? Sounds good. So then dv is going to be the other guy, right? Alright. You guys get a 30-second head start, maybe a 60-second head start. Do what you know to do. You're welcome. I gave you a hint in the notes already as to what we're about to do. Take a second. We all started the same way, at least as far as those of us that are together. My question to you is, have I plugged into integration by parts correctly?
Yeah, I got that.
1,
Because it's minus a negative, so I made it a plus, and 2 over 4 I made 1.
Oh, it's not 1. Oh, I was in.
Do you see how if you just say, like, oh, you get simpler, dv is something I can do you see how some people will get really stuck right about now?
Yeah.
It didn't make a difference. But they cycle. So what if I go again?
Go and the back. Go back to.
Okay, go for it. Go for it. Remember, I just don't want. Yes, you're right. It does go back. Remember I said up at the top when you're writing notes, it goes full circle. Just hang in there. I said if you pick the trig piece, stick with the trig being used. Pick the exponential and the dv, stick with the exponentials and the dv. Don't go switching them.
Because in the AP, you chance taking a long time or short time.
Steve, they're just gonna cycle. How long would you do that for?
Just wait.
You
see, hold on. You see that it cycles. You see, and that's the point. Just hold on. Most kids, the first time they see this problem without any further study or any further application, see that it cycles, goes full circle, and they're like, ugh, fail. But up above, I said it goes full circle in a good way, so hang in there, that's the point.
Oh, you saw that. Oh,
If you see something good, keep it to yourself. Yeah, but keep it to yourself. A lot of people don't see that. Don't shortcut their learning process. So you keep the first part, right? No, it's not a bad thing. Just keep it to yourself.
I just saw it right now.
Good. Those of you that see it, let them struggle with it. Those of you that see it, let them struggle with it. The majority, the first time you see this, you're like, but that didn't help anything.
Oh, you want?
But As long as I haven't made a mistake. If I've made a mistake, let me know, but otherwise, shush.
I didn't get it. No,
Give him time to look at it.
so
Why is it good that it's gone full circle? Don't answer. How do you guys see why it's good? Raise your hand. Okay. Don't talk. Usually what I have to point out for someone who's been introduced to this for the very first time and has solved it for the very first time is I'm like, don't forget where you're coming from. For those of you that haven't seen it yet, don't forget where you're coming from.